Fundamentals of Electrical Circuits. I'm starting lecture 15. In this session, when you have to concentrate the concept of nodal analysis. How to solve the different models of questions by applying the nodal analysis, when you have to concentrate. All of you well know this. A nodal analysis is nothing but a combination of KCL plus Ohm's law. But there is a concept of super node analysis. What exactly super node? Later on that I will discuss. KCL plus KVL plus Ohm's law is the super node analysis. Simply remember, students, a nodal analysis is the combination of KCL plus Ohm's law. A super node analysis is KCL plus KVL plus Ohm's law. Therefore, nodal analysis is KCL plus Ohm's law. I already told this formula. How many number of independent nodal equations are required? NP minus 1, where NP is the number of principal nodes. What is the simple node? What is the principal node? These points I already discussed in the previous sessions. Please go through it. And this statement also I already told what exactly planar network, what is the non-planar network. But nodal analysis is applicable for both planar and non-planar networks. How to apply this nodal analysis for both planar and non-planar networks. But mesh analysis is applicable only for the planar networks. But nodal analysis is for both planar and non-planar networks. In general, these are the steps you have to follow to solve the problems using nodal analysis. Point to remember, students, same problem you can solve by using nodal analysis or mesh analysis. By practicing more number of questions, then you get idea which method you have to apply for easily solve. That is the only way to identify which method you have to apply to solve this problem. Once you can practice more and more number of problems, then easily you can get idea. First, I am explaining some models of questions with respect to nodal analysis. First, you will see normal nodal analysis. Then later on, you will see super nodal analysis. After completing this, then you go for the mesh analysis. In nodal analysis, select reference node. Take any one node is the reference node. That node is considered as a zero potential node. Take any node is the reference node, and that node is taken as a zero potential node. And identify the principal nodes. How many number of principal nodes are there that you have to identify? What is the principal node, friends? The node which is connected with more than two elements, that is taken as a principal node. And in all the nodes, you have to identify the voltages as V1, V2, and so on. V1, V2, V3, and so on. And at every node, apply KCL and Ohm's law. Then by solving that, we can get the what are the parameters you have to calculate, that parameters. But this point also you remember, friends, I told already. With respect to any node, if the current is entering at the node, take the current is negative. With this assumption only I am explaining. At any node, if the current is leaving, you have to take the current is positive. Follow this notation. If any current is entering at the node, you have to take the current is negative. The current is leaving the node, you have to take the current is positive. With this knowledge, start with first problem. Can anybody answer this question using nodal analysis? Same problem we can solve by using mesh analysis also. But this problem is very easy to solve by using nodal analysis. You have to find Vp minus Vq. To find the Vp and Vq, you have to know what is the potential at point P and what is the potential at point Q. Once you know the potential at point P and point Q, then you can easily solve the difference between the two voltages. Now, friends, this is 10 volts means what is the voltage at this node? This is 10 volts, then voltage at this node is 10 volts. Then I am applying nodal analysis at point P. I am applying nodal analysis at point P. At point P. Let the voltage at point P is Vp. Voltage at point P is Vp. Nodal analysis is nothing but a KCL plus Ohm's law. Then at point P, this is Vp, voltage is Vp. Shall I write like this? You have to take, this is the reference node. The reference node is zero potential. This reference node is zero potential. Vp minus 0. You have to find currents. You have to find the currents. This is point P. This current is 2 amperes is leaving. This 2 amperes of current is leaving like this. Clear. Now this is zero potential. This is potential at point P is V. Then this is the current. And this is 10 volts. Now If you apply the nodal analysis at point B, students, Vp minus 0 by 3. We are calculating currents. Vp minus 0 by 3 plus Vp minus 10. This voltage minus this voltage. Vp minus 10 by, what is this resistance? 1 ohm. This voltage minus this voltage. At this node, current is leaving now. How much current it is leaving? This is the direction of current. This direction of current is, it is, this direction of current is how much means? This is 2 amperes. This 2 amperes of current is leaving now. Then you have to take plus 2 equal to 0. Now from this, solve for Vp. This is Vp by 3 plus Vp minus 10 plus 2 equal to 0. From this, Vp by 3 plus Vp minus 8 equal to 0. Vp by 3 plus Vp equal to 8. Then from this, what you can get, students? 4 Vp by 3 is equal to 8. What is Vp equal to? 6 volts we get. Vp equal to 6 volts. Then apply nodal analysis at point Q. Then at point Q. At point Q. If you apply nodal analysis at point Q, then how you can write? Vq by 2. Voltage at point Q is taken as a Vq. Then current is Vq by 2. KCL. Currents entering at the nodes. This is Vq by 2. And Vq minus 10. Vq minus 10 by this voltage minus this voltage by 1. And this current is entering. How much current is entering? 2 amperes of current is entering. I told already, the entering currents are taken as a negative. The entering currents are taken as a negative. Vp by 2, that is minus 2, equal to 0. Then Vq by 2 plus Vq minus 10, this is minus 2, equal to 0. This Vq by 2 plus Vq is equal to 12. This is 3 Vq by 2 equal to 12. From this, what is Vq you got, friends? 8 volts. Is it correct? This is 24. 24 by 3, this is equal to 8 volts. Therefore, Vq equal to 8 volts. Then what you have to calculate? What is the Vp minus Vq? And Vp minus Vq equal to 6 minus 8, this is equal to minus 2 volts. That is the final answer. This we are getting minus 2 volts. Like this, we have to solve. How to solve the problem by using nodal analysis? This one model of question. Any doubt? I taken this point voltage is Vp and this point voltage is, then this voltage minus this voltage. This voltage minus this voltage. Vp minus 0 by 3. That is Vp minus 10 by. This is our reference. From this you define Vp minus 0 by 3. Vp minus 10 by, because we are applying nodal analysis at point. Now see the one more question. Can anybody answer this? For the circuit shown in figure, you have to find the what is Vx. That is voltage across 1 ohm resistor. Come on, do it. Simple, apply the nodal analysis. Just by applying the nodal analysis, we can easily get the answers. Come on, I'm giving just 50 seconds of time. Can anybody respond? Come on, do it. Let voltage at this node is Vx. Then apply the nodal analysis and answer this question. Yes. If you apply the nodal analysis, at this node, Vx minus 10. Vx minus 10 by 2. This current is leaving now. At this node, the current is leaving. How much current is leaving? Vx by 2. If current is leaving, you will take the plus. Vx by 2. Plus. This is 1 ohm now. This is equal to Vx by 1. This is equal to 0. From this, you can solve for Vx. How much you got? Solve for Vx. This is Vx by 2 minus 5 plus Vx by 2 plus Vx. Vx by 2, Vx by 2, Vx, this is Vx, 2Vx. 2Vx equal to 5. Then what is Vx equal to, friends? 5 by 2. This is equal to 2.5. Then voltage across that 1 ohm resistance is given as a Vx now, plus minus Vx. This is Vx means voltage at this node also Vx. That is the meaning. This is Vx. You take the same voltage at this node because the same wire. This is same wire. Here Vx means voltage at this node is Vx. Voltage at this node is also. We are getting Vx equal to 2.5 volts. All of you got? Very simple. Say the one more question. It's a GATE 2003 2 marks question. GATE 2003 2 marks question. Come on. In the figure, the potential difference between P and Q is, you have to find the what the potential difference between P and Q. Same model that I already solved. P and Q, right? Same model I solve like this. 3 ohm, 2 ohm, 1 ohm, 1 ohm, 2 ampere. But here the resistance is different. This is 8 ohms, this is 2 ohms, this is 6 ohms, this is 4 ohms. Right, students? Fraction of minute you can solve. Let voltage at this node is Vp. Voltage at this node is Vq. Then at point P, apply nodal analysis at point P. Then what do you get? Vp by 8. That is Vp minus 0. This is 0 potential. Na? Vp minus 0 by 8 plus Vp minus, what is the potential at this node? This is 10 volts means this is also 10 volts. Vp minus 10 by 2. Vp minus 10 by 2. How much current is leaving? 2 amperes of current is leaving. Leaving current is taken as a positive, equal to 0. Can you try this? Vp by 8 plus Vp by 2 minus 5 plus 2 equal to 0. Vp by 8 plus Vp by 2 is equal to 3 volts. From this you calculate Vp, students. Come on, answer it. How much Vp? Yes. If you simplify that, we can get the Vp equal to 4.8 volts. Is it correct? Check it. I got the Vp equal to 4.8 volts. Next. At Q, apply nodal analysis at point Q. At point Q. Apply nodal analysis at point Q. If you apply nodal analysis at point Q, then Vq minus, this is 0 potential. This minus this by this. Vq minus 0 by 6 plus Vq minus 10. Vq minus 10 by how much resistance? 4 ohms. How much current is entering here? 2 amperes of current. Entering current starts taken as a negative. Minus 2 equal to 0. Then Vq by 6 plus Vq by 4. 10 by 4, 2.5. 2.5 minus 2 equal to 0. This is Vq by 6. This is Vq by 4 is equal to 4.5 squares. From this you calculate Vq, sir. Come on, answer it. What is the value of Vq? It's a 2 marks question. Fraction of minute we can answer. Vq by 6 plus Vq by 4. This approximately how much Vq got? Come on, do it. I got 10.8 volts. Is it correct? 10.8 volts, sir. Is it correct? Come on, do it. 4, 6, 4. Now take the LCM. Then from this you have to solve for Vq. Vq I got 10.8. Vp is 4.8 volts. Vq is 10.8 volts. The potential difference between point Q, point P and Q. That is Vp minus Vq you have to calculate. What is Vp? 4.8. What is Vq? 10.8. How much you get? Minus 6 volts. Then which option is correct? Option 3 is the right answer. Then Vp minus Vq, I got minus 6 volts. Yes, that is the right answer. Clear, friends? Any doubt? Any doubts, sir? Concentrate how to apply the nodal analysis. Still, I'm not explaining supernode. What is the supernode concept? Later on you will see. Supernode is present. How to apply also I will explain later. Next. See the one more problem. This is also gate question. In figure, the value of R is. This is gate electrical 2003 2 marks question. This also gate electrical 2003 2 marks question. This also 2003 2 marks question. But in 2003 2 sessions are conducted. That's why different session. In figure, the value of R is. Come on, students, answer. To find the R value, just we have to apply nodal analysis. Just we have to apply the nodal analysis. Take any node. But I know what is the voltage at this node. What is the voltage at this node. What is the voltage at this node, friends? 100 volts. What is the voltage at this node? 40 volts. At any node you have to apply nodal analysis. I'm taking the, at 40 volts, I'm applying the nodal analysis. At 40 volts node. At a 40 volts node. But if you have to apply the nodal analysis at 40 volts node, first I have to know what is this voltage. First I have to know what. It's very simple. What this current? This current is how much? 5 amperes. Because they given this is 5 ampere. This current is how much? Current here 10 ampere they given. That's why it is a 10 ampere. 10 ampere is leaving, 5 ampere is leaving. What is this current, friends? 15 amperes. Here, this 15 amperes of current is passing through 2 ohm resistor. This is 15 amperes of current. 15 into 2, 30 volts. Then what is the voltage at this node? 30 volts. Your answer is over. First, see the current. Here they given 5 amperes now. Current in this path is 5 ampere. Current in this path is 10 ampere. This is 10, this is 5 means what is this current? 15. 15 into 2, 30 volts. Then what is the voltage at this node? Then apply nodal analysis at 40 volts node or 100 volts node. We can get same answer. I'm taking 40 volts node. Then 40 minus 30 by 1, sir. 40 minus 30 by 1. Clear? Next. 40 minus this one. 40 minus 100. Voltage at this node 40. Voltage this node 100. 40 minus 100 by R. 40 minus 100 by R. How much current is entering here? How much current is entering? 5 ampere. Minus 5 equal to 0. Then 40 minus 30, 10. 40 minus 100 minus 60 by R minus 5 equal to 0. Minus 60 by R, 10 minus 5 plus 5 equal to 0. Then 60 by R equal to 5, sir. From this, what is R, students? 60 by 5. This is equal to 12 volts. The resistance R equal to 12 volts. Fraction of minute we can answer. Option 4 is right. Is it clear? Any doubt? This is GATE 2003 2 marks question. See how simple it is. I'm getting R equal to 12 volts. Clear? Next. See the one more question. This GATE 2003 2 marks question. Okay. Can you answer this? What is the power delivered by the dependent source? What is the power delivered by the dependent source? You have to find what is the power delivered by the dependent source. Come on, students. Anybody? Apply the nodal analysis and you have to calculate what is the power delivered by the dependent source. Come on, do it. Come on, anybody? Power delivered by dependent source is how much? 24 watt. Any answer? Yes. Listen, sir. How to answer this? You know the what is the current of the dependent source? What is the dependent source current? Dependent source current. How much, friends? Come on, do it. The dependent source current equal to V1 by 5. V1 is how much? 20 volts. 20 by 5, 4 amperes. You know what is the current delivered by the dependent source is 4 amperes. But how much power is it is delivering? You know the voltage also. Let this voltage is V. If this voltage is V, then voltage at this node is also V. Because this is same wire now. This is same wire. V. Now to find this V, apply the nodal analysis. If you apply the nodal analysis, V minus 20 by 1 plus V by 1. How much current is entering? 4 amperes is entering. Minus 4 equal to 0. That is V minus 20 plus V minus 4 equal to 0. Then 2V equal to 24. V equal to how much, friends? 12 volts. Now, what is the power delivered by dependent source? Power delivered by dependent source. Power delivered by dependent source. Can anybody? Now you tell the answer, sir. How much voltage? 12 volts. How much current? 4 amperes. Voltage is 12 volts. Current is 4 amperes. 48 watts is the right answer. Option A is the right. Yes, very good. It's a 48 watt. The power delivered by the dependent source equal to 48 watts. Clear? Yes. It's not 24, it's a 40. Please correct it. Yes. So one more question. Can anybody answer this? If the power dissipated by 6 ohm is 0, the voltage V is dash. In this circuit, the power dissipated by the 6 ohm is 0. power dissipated by the 6 ohm is 0, then you find the what is the voltage V. That is this voltage you have to find. This voltage. Apply the condition. What the condition they given? Power dissipated by 6 ohm resistor is 0 source. The power dissipation by 6 ohm resistor, that is I6 square. Let the current through 6 ohm resistance is I6. Then I6 square into 6 ohms equal to 0. Then what is I6 equal to 0? That is the current through the 6 ohm resistance is 0. The current through the 6 ohm resistor, let this is I6. If I6 equal to 0 means, how to define this current, students? How to define I6 equal to V1 minus V2 by 6 plus J8 equal to 0. From this, V1 minus V2 equal to 0. Then what is V1 equal to, students? V2. One condition we got, V1 equal to V2. This one relation we got. Now, apply nodal analysis at node 1 at V1. At V1. If you apply nodal analysis at V1, V1 minus 20 by 1 plus V1 by J1, V1 by J1 plus V1 minus V2. But what is V2 equal to V1? V2 equal to V1. V2 equal to V1. That is V1 minus V1 by 6 plus J8. 6 plus J8 equal to 0. From this, you have to solve for V1 steps. You have to solve for V1. Once I know the V1, calculation of V is very easy. For that reason only I am calculating V1. Solve for V1. V1 minus 20. Yes, V1 minus 20 plus V1 by J1 is equal to 0. Then take V1 is common. If V1 is common, or you can write like this now. V1 minus JV1. Bring this J into the numerator. We can get minus J is equal to 20. Then V1 is common. 1 minus J1 is equal to 20. Then V1, you find the magnitude and angle steps. V1 into 1 minus J1 equal to 20. What is the magnitude of this? The magnitude equal to square root 1 square plus 1 square. Tan inverse, rectangle of tan inverse minus 1 by 1. How much you can get, students? Root 2 at angle of minus 45. I'm finding magnitude and angle. Then shall I write like this? V1 into root 2 at angle of minus 45 is equal to 20. From this, what is V1's 20 by root 2 at angle of minus 45? How to simplify this? V1 equal to 10 root 2 at angle of plus 45 degrees. This is V1 calculation. But you have to calculate not V1, you have to calculate the V. Then to find V, apply nodal analysis at V2. Then at V2, I am applying the nodal analysis at V2. At V2, if you apply the nodal analysis at V2, V2 minus V1 by, this V2 I am applying, V2 minus V1 by 6 plus J8. V2 minus V1 by 6 plus J8. Next, V2 by 5 plus V2 by 5. Next, V2 minus V by 5. V2 minus V by 5. By 5 equal to 0. But what is V2? You already know. But V2 equal to V1 now? Substitute here. V1 minus V1 by 6 plus J8 plus V1 by 5 plus V1 minus V by 5 equal to 0. This is 0. V1 by 5 plus V1 by 5. V1 by 5 plus V1 by 5. Yes, friends. Is equal to V by 5. Then 2V1 equal to V. Then what is V equal to 2V1? 2 into what is V1? 10 root 2 at angle of 45. This I calculated now. Then what is V, students? 20 root 2 at angle of 45 degrees. 20 root 2 at angle of 45 degrees. Then the value of V equal to 20 root 2 at angle of 45 degrees. That is option B is the right answer. Any doubt? The concept very simple. They given power dissipated by 6 ohm resistor is 0. I applied this condition. I got one relation. Then applied the nodal analysis at V1. I calculated V1. Apply the nodal analysis at V2. I got the relation between V and V1. Then finally I got the V value. That is 20 root 2. But this model is not framed, but you can expect. It's important one. It's expected model of questions. Clear? Oh, next. Concentrate. One more question. It's very simple. Can anybody answer this question? Fraction of minute you can answer. In this circuit, find the V2 by V1. Find the V2 by V2. This is R1. This resistance is R1. In this circuit, find the V2 by V1. This resistance is the R. Come on, do it. This is V2 means what is the voltage at this node, students? V2. Can anybody define what is I equal to? V1 minus V2 by R1. V1 minus, from current is starting from V1 now. That's why V1 minus V2 by R. V1 minus V2 by R. Now, apply nodal analysis at V2. Apply nodal analysis at V2. If you apply nodal analysis at V2, that is V2 minus, if you apply nodal analysis at V2, then V2 minus V1 by R1, V2 minus V1 by R1, plus V2 by R1, plus V2 by R1. This current is entering at this node now, entering. Then minus 2I equal to 0. Minus 2I equal to 0. Then V2 minus V1 by R1 plus V2 by R1 minus 2 into, what is I? I equal to V1 minus V2 by R1 is equal to 0. Take R1 is common. You send this side, this becomes 0. V2 minus V1 plus V2 minus 2 into V1 minus V2 is equal to 0. Very good. Option B is the right answer. Very good. Then V2 minus V1 plus V2 minus 2V1 plus 2V2 is equal to 0. V2, 2V2, 4V2. 4V2 minus 3V1 equal to 0. Then 4V2 equal to 3V1. You have to find V2 by V1 now. Then what is V2 by V1, friends? 3 by 4. This is the final answer. That I got V2 by V1 equal to 3 by 4. That is option B is the right answer. Clear? Yes, friends. Any doubt? Next. Can anybody answer this? Find the unit. How to find the what is it? Here, there is two methods are there for this problem. One method is apply nodal analysis at E1 at 1. Apply nodal analysis at E0. Method 1, I am leaving for you. Method 1. At E01, apply nodal analysis. Apply nodal analysis. At E0, apply nodal analysis. Apply nodal analysis. Then solve two equations. Solve two equations. We can get E0 and E0. That is one method. That I am leaving for. Next. I am explaining second method here. Method 2. Without solving two equations, simply you can get the answer like this. It's very simple. I have to eliminate one node here. To eliminate this node, just apply the source transformation. Apply the source transformation. To eliminate the node, apply the source transformation. If you apply the source transformation here, this is the source transformation. Method 2. Apply source transformation. Apply source transformation. If you apply source transformation, this is current source. You convert into voltage source now. Current into resistance. 8 into 10. 80 volts. Current direction is like this now. That's why this is plus, this is minus. This is 80 volts. 8 into 10, 80 volts. And we are converting current source into voltage source. The resistance comes in series with voltage source. 10 volts. I already explained how to apply source transformation. Already, how much resistance is there? 2 ohms. Already 2 ohms is there. Then as it is remaining circuit you draw. This is 16 volts. And this is 6 volts. 6 volts. And this is 12 volts. Clear? Now, how many nodes here? How many principal nodes? Only one principal node. Na? Let they taken this voltage is E naught. Now apply modal analysis at E. We can easily get the answer. E naught minus 80 by E naught minus 80 by 10 plus 2, 12 plus E naught minus 16. This is plus minus na 16. E naught minus 16 by 6 plus E naught by 12 equal to 0. This E naught by 12 minus 80 by 12, E naught by 6, E naught by 12 is equal to 0. E naught by 12 plus E naught by 12 students. E naught by 6 plus E naught by 6. These two we can add E naught by 6. This already E naught by 6 is equal to 80 by 12. E naught by 6 plus E naught by 6. 2 E naught by 6. That is E naught by 3. E naught by 6 plus E naught by 2. This is equal to 80 by 12. 3 ones, 3 fours. 3 ones, 3 fours. Then how much? Any? Yes, something is missing here. 16 by 6 is missing. Sorry. Once again I'm writing. 16 by 6 is missing. It's minus 16 by 6 plus E naught by 12 is equal to 0. Now can you answer this? Sorry for this. Can you answer now? From this you solve for E naught by 12, E naught by 12. That is E naught by 6 plus E naught by 6 is equal to 80 by 12 plus this is 2 8s or instead of 80 by 12. This is 2 40s, 2 6, 40 by 6. 40 by 6 plus 16 by 6. This is E naught by 3. E naught by 3 equal to 56 by 6. 3 ones, 3 twos, 228s. What is E naught? I got 28 volts. Is it correct? E naught equal to 28 volts. That is final answer. Very good. That is correct. 28 volts is the final answer. Is it okay? See, all these problems I'm solving just by applying nodal analysis. Just by applying nodal analysis. But here, the advantage of source transformation is one node is eliminated. Then solution is very easy. Same problem we can solve like this also. Apply nodal analysis here, we can get one equation. Apply nodal analysis here, we can get one equation. Solve two equations, we can get that answer. But somewhat that is lengthy problem. Here we have to get idea. If you get this idea, problem becomes very easy. Solution is very easy now. If you don't get this idea, it takes more time. Sir, how we can get that idea, sir? No other alternative. You practice more number of problems. By practicing the problems only, you can get the idea. The only way to get the more confidence in the network theory by solving the many number of questions. If you solve more number of questions in network theory, you can easily get the ideas. Within less time, you can solve it. That point. Any doubt? I'm adding one more question here. Just a minute. Can anybody answer this question? This is a GATE 2004 2 marks. Find the value of source voltage. E. It's very simple, sir. I don't know about this voltage. Once you know this voltage, apply nodal analysis here. We can easily get the answer. Or even by applying KVL also, you can get the answer. Then how to know this voltage? Simple. This current is how much? 1 ampere. This current is how much? 2 amperes. This 1 ampere, this 2 ampere. What is this current? 3 amperes. 3 amperes of current is flowing here. This is how much? 18 volts. 18 volts. No need to apply nodal analysis. Just KVL also you can easily get. How much current is entering here? 2 amperes. 2 amperes, 6 ohm resistor. Na? Wherever the current is entering, that is plus. This is minus. This is 12 volts. 6 into 2, 12 volts. Simply you can apply KVL. Or by applying nodal analysis also you can get answer. No doubt. Simply you can apply KVL here. Students. Positive to negative. Negative. Sign convention is important. Minus 12 volts. Positive to negative. negative, minus 18 volts. Negative to positive, plus E equal to 0. How much E, sir? 30 volts. See how simple it is. It's a 2 marks question. Just you have to get some idea. Clear? Any doubt? Can you try for nodal analysis at VA? What is the voltage at this node? Voltage at this node is 18 volts. 18 minus E by 6. 18 by 6 minus 1. Check the answer, final answer. You get 30 volts. That like that also you can solve. Clear? Just already current directions, according to this, I calculating this voltage. Just apply KVL, I got the 30 volts. This I'm leaving for you. You have tried this problem for practice. You find the V1 and V2. Find the V1 and V2. Find this V1 and V2. How to find V1 and V2? This is V1. This is V1. This is V2. Apply nodal analysis at V1. Apply nodal analysis at V2. Two equations we can get. Solve for two equations. Then we can get V1 and V2 students. Solve for that. We can get V1 and V2. Clear? See the one more question. I'm adding that. Just a minute. Can anybody answer this? Determine E and I. This is also previous gate question. Here I'm not remember this. Here is a previous. Determine E and I. For this, no need to go for nodal analysis, all this. Just by KVL only you can easily find. Yes, sir. Come on, do it. It's very simple. Start from this one. 2 amperes of current is flowing through 4 ohm resistance. What the voltage? 8 volts. If this is 8 volts, this is also 8 volts. Why? Parallel. If this is 8 volts, what is this current? 8 by 1. 8 amperes. If this current is 8 amperes, this current is 2 amperes. What about this current? 10 amperes. If it is 10 amperes, this voltage is 10 volts. 10 into 1, 10 volts. If it is a 10 volts, apply KVL here. Find the voltage across 6 ohm resistor. Find the voltage across 6 ohm resistor. This is 10 volts, this is 8 volts. Then what is the voltage across this 18 volts we can get? Because some of all the voltages must be 0. If you want to apply KVL, this is 10 volts, sir. Positive to negative, minus 10. Positive to negative, minus 8. Negative to positive, plus V6, equal to 0. What voltage across 6 ohm resistor? 18 volts. This is plus minus 18 volts. It's 18 volts. Clear? If it is 18 volts, this is 18 volts. Now what is the current here? Come on, wait. If it is 18 volts, what is the current here? 18 by 6, na? 3 amperes. 18 by 6, 3. This is 3 amperes, this is 10 amperes. Then what about this current? Come on, sir. What is this current? It's a 13 amperes. Very good. This is 13 amperes. That is what the current I? I equal to 13 amperes. If it is a 13 amperes, what is the voltage here? Plus minus 13 volts. This is 13 volts, this is 18 volts. This is how much, sir? Put it up like KVL also. Directly you tell me. In this loop, some of the voltage must be equal, na? This is 13, this is 18 means this is how much? 31 volts. Clear? This is 31 volts. If you apply KVL here, some of the voltage is 0. That's why option B is correct. 31 volts, 13 amperes. See how we are solving this problem. Starting from this, just by calculating voltages and currents only we are solving this. Yes, 31 volts, 13 amperes is the right answer. Yes, friends. This about nodal analysis, some models of voltages. Next, we have to see super node analysis. So today, Sunday, I already taken some offline classes also. time being, I'm taking only 1 hour. Actually, 7 to 8:30. I'm taking only 1 hour. So from tomorrow onwards, I will take 1.5 hours. Then tomorrow we'll continue with the super node analysis. After completing super node, then mesh analysis, super mesh analysis. With that, the concepts will be complete, and you will see some practice questions. Then you start. Students, any doubt? Thank you very much for attending the session. Once again, please go through this whatever I explained. I will share
Excuse me,
this. Yes, tell me.
Sir, when we are going to, sir, so can we solve the questions using source transform theorem also? Or
You have to source transformation questions.
yes, sir.
Yeah, in the next section is
Okay, sir.
actually that source transformation questions will repeat in the theorems. There is Thevenin's theorem and Norton's theorem is there now. In that, more number of questions will come. Is it okay?
Okay, sir.
That will repeat in the theorems. But you will see some questions also. But more number of questions will come using dependent source, how to apply source transformation. All these will repeat in the theorems. Thevenin's and Norton's. There also you will see the more number of questions. Thank you.